Hi folks, welcome to an introduction to statistics. Today we're going to be getting things rocking and rolling in terms of what it means to be a variable and an individual in a statistical study. So let's get started. Statistics, what is it? Well, basically think of collection, analysis, presentation of data. Data, that's what you should be thinking when it comes to statistics. We're doing all sorts of things with data sets. So with these data sets, some of the things we need is first off the individuals. And these are the objects that are described by a set of data. And along with those individuals, each individual should have some sort of variable. And the variable is the characteristic of the individual that we're looking for and looking to study. So the best thing to do to get moving forward is actually take a look at some examples. So suppose you wish to collect data from the graduates of Armstrong State University that majored in mathematics with a focus on statistics. You want to find the industry in which the aforementioned graduates were employed. The responses included genetics, risk assessment, law, insurance, marketing, and pharmacology. What are the individuals in this data set? So who's the people that we want to collect information from? Well, if you notice up at the top, we want to collect data from the graduates of Armstrong State University that majored in mathematics with a focus on statistics. So that right there tells us who our individuals are, who we're trying to collect data from. So we have that information. Next question, for each individual, so we have all those individuals graduating in mathematics, what's the variable that we're actually looking at? So what's the thing, the way I try and think of it is what is changing? The thing that's changing is the industry in which they're employed. If you notice, we have different responses: genetics, risk assessment, law, insurance, marketing, pharmacology. All of those are different types of places they're employed. So the industry in which we're having our graduates employed, that happens to be our variable. Okay, moving forward. Must individuals always be represented by people? Well, when you think about it, we just did, for example, the graduates, but did it have to be graduates? Could you do other sorts of studies? Well, yes. It doesn't really matter. You could do things like lengths of crayons. You could do numbers of lions, tigers, and bears, or something like that. How long their hair is. The stock market, that's a great example. The list goes on and on. If you can think of a person, place, or thing, I guarantee we can find some sort of statistical study done on it. So there's a challenge for you if you want to try. But that's what we're keeping in mind. Individuals can come in all shapes and sizes. Okay? And let's think about, do we have only one associated variable? Well, this should be an immediate no. I can give you an example real quick, and that's when we go into the doctor's office. There's all sorts of variables they're checking for right away. So, in fact, we have sex, height, weight, the blood pressure, pulse, temperature, and the list goes on, depending upon what kind of work you're having done. But that's just as soon as you enter a doctor's office. So, when you think about it, the individuals and the variables have a wide range. So that's why we have to read and analyze what's going on in our statistical studies that we have. So with those variables, with there being all sorts of types of variables, we want to try and put them into two different areas. One is called qualitative and the other is called quantitative. Qualitative, you see this term categorical there. The reason why a qualitative variable actually puts things into categories. So every individual in our study, the variable itself will have some sort of category it falls into. In a similar manner, a quantitative, you can think of the word quantity, so some number involved. And don't get confused, it's not a numerical category. Sometimes that can happen. You'll see that coming up in just a little bit. Little foreshadowing there. So quantitative, we're looking for a measurement of some characteristic of an individual. So if we go back, let's look at that example of Armstrong State University that majored in mathematics with a focus on statistics. There are all sorts of industries in which they were employed. Okay, you had risk assessment, you had law, you had insurance, I think pharmacology was another one. So But when you think about it, is it a numerical value? Is it some sort of measurement? Or are we placing them into categories when we're looking at the variable? Well, you should answer that we're placing them into categories. So that means we have a categorical or qualitative variable, right? And there's the list actually that we mentioned a second ago of the categories that actually go in play. So, moving forward. Let's take a look at another one and maybe we can identify the variables. If you have, going back to the emergency room, doctor is collecting the patient's sex, height, weight, both types of blood pressure there, and then pulse, temperature, and an emergency room experience on a 1 to 5 scale, with 5 being most enjoyable. Sometimes they're trying to rate how things are going. So in this case, what are your qualitative variables? So you might think, okay, sex, that's male or female, right? So those are categories, so that should be in there. Height, maybe not so much, because usually height is determined by a number, and usually in the U.S. system, it's the U.S. customary system, it's feet and inches, things like that. Same thing with weight, we have measurements in pounds. Systolic and diastolic blood pressure, those are both measured as numbers, right? You have 100 over 70 or something along those lines. So we have numbers once again. Pulse, same thing, pulse rate around 60 beats per minute. Temperature, usually hopefully 98.6 degrees Fahrenheit, but that can vary just slightly. Emergency room experience on a 1 to 5 scale. Notice those are numbers, but wait 1 second. If you think about it, you can change the 1 to 5 scale to be with poor experience, very good experience. So basically what we're doing is we're putting a person into a category on how they felt about their emergency room experience. So what we actually get out of these, the qualitative variables are the patient's sex and the emergency room experience on a 1 to 5 scale. Okay. Now moving forward, that means if this is your qualitative, the only other type of variables are quantitative, so all the others must be quantitative. Okay. So moving forward, qualitative, there's some other things that we have. You have a nominal data if you have grouping of individuals into observations into categories. Right? But now ordinal, you're still grouping them into categories, but those categories can be ranked now. So let's look back. First off, we have to talk about qualitative data. And our qualitative, the only possibilities are sex and then that Likert scale type thing appearing at the bottom. So what is the nominal data set? So we're just putting them into categories. There's no ranking system in this case. So in terms of the only one that's put into categories and no ranks involved, well, male or female. I know some of you might say, oh, females are much better or males are much better. There's no rank when it comes to that. So the nominal data set is in fact just the sex. Because the 1 to 5 scale, 5 being most enjoyable, that's the rank that they want the most. That's the highest ranking for those people in the emergency rooms, serving the general public. So does there exist any ordinal data within this example? Yeah, the 1 to 5 scale, so for our emergency room experience, right? And the numbers 1, 2, 3, 4, 5 represent those categories that can be ranked. Okay, moving forward. So now we get back to the quantitative sides of things. So the quantitative sets, we have things called discrete and continuous data. And this will be kind of hard to distinguish, but discrete, there's only a finite number of values, or if you do have an infinite number of values, there's always a space, right? So that means you can't keep on breaking down. You can't say 1.5 and then 1.57 and 1.578. So meaning the significant digits can't range from 1 to infinity. There's some stopping point. So now continuous, on the other hand, you have any possibility in the number system within a finite interval or an infinite interval, depending upon what you're looking at. But so we could say any number between 0 and 1 could be a possibility. There's an infinite number of numbers between 0 and 1, right? 0, 0.5, 0.51, 0.512, 0.5123. And I could keep on doing a general trend as far as I wanted. There's no way you'll be able to count all those numbers. And there's no gaps between them. So let's take a look at an example between discrete and continuous. Suppose you want to collect data on the city of Savannah. The information you wish to collect about the city involves the number of people, the the average height above sea level, and the average age of, oh, not the average age, my apologies, the age of the buildings within a given region of Savannah. So, the discrete data in this case is the number of people. And why is that? Well, you can't have a half a person or 3/4 of a person. That just doesn't happen. So that means that's discrete data. There's gaps between numbers. In fact, you're having 0, 1, 2, 3, so on and so forth. But wait a second. The average height above sea level. Well, if you think about it, places like New Orleans and stuff, they're below sea level. Granted, we might be above sea level in most of our locations, but you have some range here in terms of it could be any number. And what I mean by that is, depending upon how accurate you want to measure, we have all sorts of possibilities. So if someone said we're 37 feet above sea level or 100 feet above sea level, that's fine. But you could also say 100.1 or 100.12 or 100.123 feet above sea level. All of those are possibilities. Age of the buildings, you might say, come in whole numbers as well. But once again, that depends upon our measurement system. If you're talking, most people think age of buildings around Savannah in years, but we could get it down to, say, maybe someone wants to do it in years and days. Someone wants to do it in years, days, hours. Someone can go all the way down to seconds or milliseconds. All of those are possibilities, and they are valid answers. So with there being no gap in possible answers, we have those last two are actually continuous data. I know that can be a bit tricky, so please take some time, maybe even pause it if you're struggling with that. So it depends upon our accuracy of our measuring device, how many significant digits we can take it out. If you notice, as I mentioned before, the number of inches we can measure for height above sea level, feet, same thing. You can keep on continuing that calculation on out. So moving forward now, I forgot to say, also the age, my bad. So now the other types of data that goes here is ratio data, and basically that has 0 as a natural starting point when we're dealing with our quantitative data sets. And then interval data, it can be any number. 0 is not necessarily a natural starting point. So looking back at our example that we just had on Savannah, the three things, where we had the number of people in the city, the average height above sea level, and the age of the buildings. Well, when you think about the ratio, the interval and ratio data, the ratio data should have 0 as a natural starting point. The number of people, you never have -1, or you never start at 100 necessarily. You always start at 0 and then add people from there. So natural starting point is 0, so that means it's ratio data. Same thing goes for the age. You start at some starting point when the building's first built at 0, and it builds from there. Okay? So even though we have continuous data and discrete data, both can still be ratio at the same time. Just keep that in mind. However, now, after having those two, you have to think about the interval. Why is average height above sea level going to be interval data? Well, notice we can be below sea level or above sea level. So there really is no natural starting point. And with that in mind, we know that average height above sea level happens to be interval data. Okay? So finally, we're going to start to make a move on distributions, because that's what we really want to collect information about, build towards information about a population. So distribution of a variable that describes what values the variable can take and how often it takes, that's what a distribution is. So what we try and do is we will get a nice presentation, and we'll learn about that a little bit later in the semester. But keeping that in mind, we're going to have a starting point for these distributions. How can we display the data? Well, the nice way to display this is basically forming some sort of frequency or relative frequency chart or table, whatever you may want to call it. And so the distribution of our categorical variables look really nice in a frequency table or a relative frequency table. And that's what we're going to do right here, and how to form them. So remember, relative frequency, that's going to be dealing with the percent for our counts. And frequency, obviously, those are just our counts. And there's also something called cumulative frequency as well. Just kind of keep that in mind. So after polling the people attaining their doctorate in psychology in the state of Georgia, we find the distribution of the branches of psychology in which they work as indicated in the table below. We shall create a relative frequency table from the provided results. So let's say we have this information here. You have abnormal psych has a frequency of 170, behavioral psychology has a frequency of 48, and so on and so forth on down the list, all the way to social psychology being 330. First question, how can we find the relative frequency of each branch? Well, remember, relative frequency is a percentage. In order to get a percentage, when you're given this information, we need a total. So the very first thing we need to do is find the total. So we need the total number of people involved in that survey. So with that in mind, we have this. All we'll have to do is add on down. Add 170 plus 48 plus 22 plus 203 plus 105 plus 17 plus 330. I believe if I've done the math correctly in my head, I think that's 895. And yes, what do you know? It is. Okay, so now we have our information. How do we turn that frequency into a relative frequency? Well, it's not too bad either. All you need to do is begin by taking 170, dividing that by 895, and then to turn it into a percent, if you want it as a percent, multiply it by 100. So that's exactly what's explained right down below. So take the number of people in each given branch, divide by the total number of people, which is 895, and multiplying by 100. So 170 divided by 895 times 100. Notice what we'll have first is 19.0. So notice we're going, we have 3 significant digits in this case. And we'll always basically just round it off to the nearest tenths place in all these cases. When you look at behavioral psychology, you take 48 divided by 895, and then multiply that by 100, and you'd have 5.4%, once again rounding to the tenths place. Keep on moving forward. For cognitive psychology, 22 divided by 895, multiply that by 100 to turn it into a percent. We get 2.5%. We continue with developmental psychology. You take 203 divided by 895, multiply that by 100, and you get 22.7%. Experimental psychology, you take 105 divided by 895, multiply by 100, you get 11.7%. Forensic psychology, you take 17 divided by 895, multiply by 100, you get 1.9%. And finally, social psychology, you take 330 divided by 895, and multiply by 100, and you get 36.9%. Let's think about what should happen when we sum all the things in the right-hand column. Well, if we've done this correctly, we should have 100%, right? Because the grand total, 895 divided by 895, would be 100%. However, if you take the time to go through this, you'll find that you have 100.1%. So why is that inaccurate? What happened here? Well, the reason, it goes back to our significant digits and things of that nature. When we rounded off at the tenths place, rounding up or down actually caused a slight bit of error. And so that round off error is the reason why we have a little bit of a miscalculation. So there's ways to remedy that, and one of them is going to be a cumulative relative frequency diagram, or table, I should say. So if you have any questions on this, please shoot me an email, joshua.lambert@armstrong.edu. I hope your homework goes well, and keep up the good work.